The third and final method in solving a system of equations is called elimination, and the elimination method is a method in solving a system of equations, which I'm just going to say a system, where the goal is to eliminate or cancel out a variable through adding or subtracting the two equations. Okay, so in the elimination method, we're not going to be needing the same setup as substitution. Step one in this process is to make sure the equations are lined up. That means that we need to have two equations in the same form. So the two equations can both be in slope-intercept form. They can both be in standard form. We're not really typically going to see them in point-slope form, but they need to be lined up in that we've got the same exact equations in the same form. Then step two, what we would do is either add or subtract the equations to eliminate the variable with common coefficients. Now let me remind you, coefficients are the numbers in front of the variables. So what we're doing here is we're trying to either add equations together or subtract equations. And the way that we do that is by deciding, do they have the same number in front of the variables? Do they have the same coefficients? Because you would subtract to cancel out the same number. Or are they opposite? In that case, you would add to cancel them out. And then step three, you solve for the remaining variable. And once you have one answer, then elimination is technically over. Then what you would do is finish out the rest of the problem actually with substitution. So then you substitute your answer into either original equation and then you solve for that variable. So even though elimination starts out differently, you end up getting an answer and then you really use substitution in the end to solve it. So number one is kind of different than the rest. So I actually want to skip number one for now and move to number two, and we'll come back to number one. So number two, we have x plus 4y equals 13 and x minus y equals 3. Elimination does not require you to solve for a variable and then substitute it in like the substitution method requires. Elimination requires you to look at the coefficients of x and y. This is 1x, this is 4y, this is 1x, this is negative 1y. Your whole goal is to be able to take these equations and either add them to eliminate the variables or subtract them to eliminate the variables. And it really depends on what type of numbers you have in front of the variables. So let me show you what I mean. If we were to take these two equations and add them straight down, we would add the x's together and we would get 2x. We would add the y's together, 4y plus negative 1y is 3y equals, and then we would add these together, this would be 16. Now that didn't help us out at all. We took two equations, we added them together, and nothing eliminated. But if we, instead of adding, if we subtract these two equations, then look at what will happen with just one of the variables. If I subtract x minus x, they eliminate, they cancel out. So subtraction would be the way to solve this system because the coefficients are the same. Then we would do 4y minus negative 1y. We have to just be careful with that. 4 minus negative 1 is technically 4 plus 1. So this is going to be 5y equals 13 minus 3 is 10. Then we divide by 5 and we're left with y equals 2. So what we did here is we took the two equations and we subtracted them, and you specifically have to subtract the top number minus the bottom number for each and every part of this. You can't flip the order around or else it's going to be wrong. Once we get one answer, we know we have the problem halfway done. Y is equal to 2, but even though we're using elimination as our process, we actually still have to use substitution. So you pick an equation you like better, doesn't matter. X plus 4y equals 13 is the one I'm going to use. I'm going to replace a 2 in for y now that we know what y is, and then I'm going to solve it out. Basically, what plus 4 times 2, which is 8, is equal to 13. It's going to be 5. If I subtract 8 from both sides, I get x equals 5. So altogether, my answer is 5, 2. So when you have the same exact coefficient, you're going to subtract. So when you have the same coefficients, you're going to subtract the equations. So we can kind of remember this as same, subtract. When we have opposite, which I'll do one like that next, coefficients, which remember coefficients are the numbers in front of the variables, we're going to add the equations. So opposite add, same subtract. So I'm going to skip down to actually on the other page, number 5, just so that we can see that situation. So if I look at number 5, we have got 4x plus 9y equals 5, and negative 4x plus 7y equals 11. Now if I'm looking at the coefficients, I'm comparing 4 and negative 4, and 9 and 7. Now 9 and 7, doesn't matter if you add them or subtract them, they're never going to cancel out because they're just completely different numbers. So that's not our goal here. Our goal is to look for either the same or the opposite numbers. 4 and negative 4 will be able to cancel out, but it won't cancel out if you subtract. If we take these two equations and we subtract them, 4 minus negative 4 is actually equal to 8. So subtracting this wouldn't be helpful because we would get 8x plus 2y equals negative 6. That's not going to help us. So instead of subtracting, what we do is we take these two equations and we add them. Why? Because when we have opposite coefficients, we're going to add the equations. So 4x plus negative 4x eliminates. It cancels out. 9y plus 7y, that's 16y, equals 5 plus 11, 16. Once we get that, we can quickly solve it out. We're going to get y equals 1. We're halfway done. We take the equation that we like better. I like the first one, 4x plus 9y equals 5. I'm going to replace a 1 in for y and solve it out. 9 times 1 is 9, so I would subtract 9 from both sides. 5 minus 9 is negative 4. When I divide by 4, I'm left with negative 1 for x. So altogether, my answer would be negative 1, 1. So going back to the original front, let me just finish out some of these practice problems. Now, some of them you really have to make sure, especially if the questions are all mixed up, you have to really be able to understand, do I add the equations or do I subtract them? So number 3, we've got 3x minus 10y equals 14. 3x minus 9y equals 15. So both of these equations are in standard form, so they're already lined up. And comparing the numbers in front of x and y, we've got 3x and 3x here, so 3 and 3. So that means what we would do to solve this would be subtract because they are the same. The only way we can cancel anything out is if we subtract, since 3x minus 3x is nothing. So then we have negative 10y minus negative 9y, which is really negative 10 plus 9. That's going to be negative 1. So we're going to get negative 1y equals 14 minus 15 is negative 1. Dividing both sides by negative 1, we're going to get positive 1 as our answer for y. We pick an equation we like better. I don't know. I don't feel like one is really better than the other. I'm just going to use the second one since I used the first one a couple of times. I get 3x minus 9y equals 15. We now know that y is equal to 1. So this is 3x minus 9 equals 15. So I would add 9 to both sides. 3x equals 24. Dividing by 3, we get 8 for x. So altogether, my answer would be 8, 1. All right, so again, it's all about really looking closely at the variables and noticing, are they the same or are they opposite? If they're the same, then you would subtract. So looking at the next problem, number 4, we've got 4x and negative 2x. Doesn't matter if we add or subtract, these will never cancel out. So that's not what we would focus on. We would focus on the y's. We have 2y and 2y. They're the same. The only way to cancel those out would be subtracting these two equations so that they go away. 4x minus negative 2x, careful, that's 6x, equals 6 minus 18, also be careful, negative 12. When I divide by 6, I get x equals negative 2. Then pick an equation that you like better. I'm going to use the first one, 4x plus 2y equals 6. Replace in negative 2 for x, and then solve it out. This is negative 8. Adding 8 to both sides, 2y equals 14. Dividing by 2, y equals 7. So altogether, this final answer would be negative 2, 7. Flipping to the next page, let's just do a couple more, making sure we understand the process when they're not the same, but they're opposite. Number 6, we have 10x and negative 2x. Doesn't matter if we add these together, that would be 8x, or subtract them. You're still not going to cancel them out. The only way that numbers cancel out is if they're the same or opposite. So that's not going to be helpful. What it is, though, is that the y's are opposites. We've got negative 3y and positive 3y. If we take these two equations and we add them, negative 3y and positive 3y will cancel out because when you add opposites together, they equal 0. So we would take these two equations and add them. So 10x plus negative 2x would be 8x, which we can always use our calculator to help us out. You would just, if you needed to, type in the numbers, no x's. And then 18 plus 6 is 24. Dividing by 8, we get x equals 3. So you might be thinking, like, actually, this is kind of easier. Now, it is easier when you've got everything lined up and it's already set up nicely for elimination and, you know, the problems are going to be working out nicely. But eventually, they will not be that way. I'll teach you the more difficult the next lesson. But for now, it's pretty easy. 10x minus 3y equals 18. We now know that x is 3, so 10 times 3 minus 3y equals 18. This is 30. We're going to subtract 30 from both sides. Okay, that's going to be negative 12. Therefore, we're going to get 4 as our answer for y. So altogether, 3, 4. All right, so back to number 1. Now, number 1 is an interesting problem because number 1, even though we have the equations lined up and they're both in slope-intercept form, usually questions with elimination will start out by being in standard form. But still, if we have two equations that are in the same form, like number 1, y equals 3x plus 4 and y equals x minus 2, we can still do elimination. What we would do is look at the y's, 1y and 1y. Look at the x's, 3x and 1x, and decide, can I add these two things together to cancel anything out? Well, no, because 1y plus 1y is 2y. 3x plus 1 more is 4x. Like, that's not going to work. Nothing eliminated. So adding is not the way that we would go about this problem. But if we do take these two equations and subtract them, look what happens. Y minus y is nothing. You would have to put a 0 there to complete the equation still. We would get 0 equals 3x minus x is 2x. 4 minus negative 2, careful, will end up being 4 plus 2, which is 6. So here's the equation we have, and then we would solve this for x. So we would actually have to move that 6 to the other side, getting negative 6 equals 2x, dividing by 2, and we would get negative 3 as our x value. Take that, replace it back in for x in your equation of choice. Y equals negative 3 minus 2. Y equals negative 5. So we would get negative 3 for x, negative 5 for y, and there is our final answer. So even though usually systems of equations in standard form lead to the elimination method being easier, you can still use it when both equations are in slope-intercept form as well. Now, the only way that these can get a little bit iffy is if we don't have equations in that same format. So we are going to make sure that we try one or two that's not. And the first one that's not is number 8. Now take a look at number 8. We've got one equation that says x equals 3y plus 11 and one equation that says 2x minus 3y equals 16. These are not lined up. If I went to like add these or subtract these, I wouldn't even know where to go because the equal sign is not in the same place. So we can't add straight down because things aren't lined up perfectly. So what we would have to do before we start this problem is make sure they're in the same format. So what I would do is keep the second equation the way that it is and move the first equation into standard form. So the first equation, x equals 3y plus 11, I'm going to move the 3y over so that this is x minus 3y equals 11. And then I can use that equation instead. So x minus 3y equals 11 is the equation I'm going to use. So forget the first one that was given. I'm not going to use that anymore. I'm going to now use x minus 3y equals 11. And I can see that I've got the same negative 3y and negative 3y. Even though they're negative and it seems a little bit weird, you still subtract when they're the same. So 2x minus x is 1x. Negative 3y minus negative 3y is nothing, and here's why. Negative 3 minus negative 3 really is negative 3 plus 3, which is nothing. So this is going to cancel out. The equal sign, 6 minus 11 is 5. So we get x equals 5. And then we take that and we put it back in for one of the equations. So you can use the original one. You can use the one that you rewrote if you need to. But I'm going to, let's say, use the second one. So 2x minus 3y equals 16. I'm going to replace a 5 in for x and solve it out. That's 10. 2 times 5 is 10, so I'm going to subtract 10 from both sides. Get negative 3y equals 6, divide by negative 3, and get y equals negative 2. So altogether, this final answer would be 5 comma negative 2. And to use elimination, we did have to add that extra step of putting both equations in the same form first before we started the process. You have to do that. And that would pop up in number 9 and 11 as well. Number 7's good to go. We've got the x's, y's, the equal signs, and the numbers lined up. Number 10 is good to go. Same thing. Everything's lined up. It's number 9 and 11 where we don't have things lined up. Equal signs are all messed up, so we would have to convert them first before we did anything else. So to practice this, instead of doing the rest of these problems, what I want you to do is get started on your homework, which is the following page. There are 8 questions. Take a look at them. Make sure that the equations are lined up as your first thing before you start, which number 1 is good to go. Number 2 is good. These are lined up. Actually, every single one is lined up, which is great. So then what you need to decide is, do you add or subtract? Remember, if you have 2 equations that have the same number, same coefficient number, subtract, same subtract. If they are opposites, like 2 and negative 2, then you would take the equations and add.